So question 12 says write the expression as a single logarithm. So one thing I'm seeing, I have 4 times the log of 7 times then the square root of 5x minus 2. So instead of using a radical, I think it'd be appropriate to raise this to the 1/2 power. This 4 is going to come back inside because of this property here. So that's kind of going on. Subtraction tells me that this is probably going to be used somehow. And then there's addition, which means this property is also going to somehow be used. So the first thing I'm going to do is rewrite this then as the log of, in parentheses, 5x minus 2 so 5x minus 2. I'll keep that 4 out there for the time being. So the square root symbol is going to be turned into a 1/2. So I have minus then the log of 7 over x plus then the log of 7 base 7. So, 7 to the what power 7, I'm also picking up on this property here. This piece here is going to turn into a 1. So as I move through here, though, my brain's going all over the place, but I want to go ahead and bring this 4 back in. So it's going to be a power to a power. So it's going to be the log of 5x minus 2 to the 1/2. But all this is raised to the 4th power. So I have like a double parenthesis there. So this should be a 4. Minus then the log of 7 over x. And I'm just going to change that to a 1 there. Now, if we have a power to a power, we can multiply those together. So half of 4 would be a 2. Or if you do on a calculator, 0.5 times 4, you get 2. So this turns into the log of 5x minus 2 squared minus then the log of, and this is all base 7s, I should say. Left that out, didn't I? Base 7s. So the log of 7 over x base 7 plus 1. So this can be then, well, I guess since they say a single logarithm, I think I may have jumped the gun on this 1 because I've got to put this all together as a single log. So let me back up and leave this as the log of 7 base 7. And just let's see what happens by leaving it like that. So since this is a quotient, this is going to be the numerator, this is going to be the denominator. So this is going to be the log of 5x minus 2 over 7 over x. So that's going to be a bracket because that's just too much there. That had plus then the log of 7 over base 7. Now, we have to simplify this 5x minus 2 divided by 7 over x. So if I do this off to the side here, so we can kind of Kentucky chicken fry it, keep change flip. So if I have this 5x minus 2 divided by 7 over x, you can rewrite this as 5x minus 2 times x over 7. So this is going to turn into, so let's go back to my green. This is going to be the log, and again, let's keep forgetting my bases. Base 7. Go back here in green. So I got my bases back in, missing a base there. see. Hey, when it does that. We did a lot of problems. So we're picking up on is this part over here. This becomes x times 5x minus 2 all over 7. So I really don't need a big parenthesis, I need really a smaller parenthesis there. So 5x minus 2, x times 5x minus 2 over 7. So this piece cleans this inside up here. So I have the log of, and then I'm going to have a bracket again. You're going to have this x times this 5x minus 2. And that was squared, wasn't it? So I lost that part. All kinds of stuff missing. That was a power of 2, wasn't it? Power of 2 over there as well. Okay. So I have that. And now this 7 goes on the bottom. And then we're going to add to that the log of 7 base 7. So since this is addition, these can go together as multiplication. So this becomes then the log of 7 times x, 5x minus 2 squared over 7. And this is base 7. But notice how the 7s will actually divide out. So there's no longer a denominator. So this just turns into the log of x times 5x minus 2 squared, like that, base 7. So that's kind of what we got going on here. So as we look at this problem again, we had the 5x minus 2, since it's a radical, the first thing I did was rewrite that using a power of a half. The next thing I noticed that this 4 had to come inside here. So this became then the log of 5x minus 2 to the 1/2 raised to the 4th power. But remember, if we have a power to a power, those multiply together and give me a 2. So that's where I got this log of 5x minus 2 squared base 7. The rest of this problem just came down. So I have minus the log of 7 over x base 7 plus the log of 7 base 7. The next thing we did is the subtraction became a quotient. So I have the log of 5x minus 2 squared over 7 over x. But this is what's called a complex fraction. So to simplify that, remember a fraction bar is a division symbol. So I can write this as 5x minus 2 squared divided by 7 over x. Remember, dividing by fractions can be changed to multiplying by the reciprocal. So we have what's called Kentucky chicken fried, keep, change, flip. So the 5x minus 2 squared stays there, but notice how I flipped the 7 over x to be x over 7. So the x and the 5x minus 2 squared become the numerator, and the 7 is the denominator. So this expression here gets rewritten then as x times the quantity 5x minus 2 squared over 7. So now it's not a complex fraction. And since now we have, again, I need my little base 7 over here. So now that we have these two logs added together, they can now be connected by multiplication. So the 7 and the x and the 5x minus 2 squared all become the numerator, and the 7 is on the bottom. But now notice that the 7s will actually divide out of the problem, and that'll give me then the log of the quantity x times the quantity 5x minus 2 squared parentheses. So you don't probably need this extra set of parentheses. I probably overkill it there. This would probably be satisfactory to put it into the computer like that. So those extra parentheses are not necessary once I kind of look at it, because this all kind of stays together.